In this set of notes, we are going to pick up where we left off on the last set of notes. In the last set, we were dealing with multiplying monomials, and in this session, we're going to deal with dividing monomials, what that looks like, and steps to take to actually go through and finish these types of problems. It may look a little intimidating, but I do promise it's a whole lot easier than it seems. So let's go ahead and get started. This may be a little bit long on the long side because there is a good bit to cover in these notes, but if you stick with it, you will know how to do all these different things. Another little tip that I see students struggling with trying to write or do any type of thing um, with these files or with these Cami documents is they do it with it completely zoomed out. If you come up here on the right side of the page and you click this 100% this zoom spot, this is where I go. This is how I do all my work. I zoom in to like level 300 and I go from there. That'll make it a whole lot easier to do your work as opposed to trying to do it zoomed out. All right, and like I said, this set of notes is going to pick up right where the last one left off. And in fact, the essential question is, for the most part, the same. How can I use operations to, excuse me, to simplify my monomials and whatnot. All right. And then even this first section of notes is the same right here. Where we get started with the rest of these notes, it's the same thing. A monomial, that's what we're starting with, is a number, a variable, or the product of a number and one or more variables with a non-negative integer exponent. All right. It only has one term. That's what's going to go here, one term. And that's what mono means. It's the root for one. Only has one term, okay? And then that's just like from the last set of notes. But here's where the new stuff starts to come in. When we start to look at this table and see what this looks like with these quotients, all right? That's what it is when we have a number over another number, when we have division happening. It's called a quotient. All right, when we look at this first example, we see we have 2 to the 5th over 2 to the 3rd. All right, so when we actually write this out, we get something that looks like 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, all over 2 times 2 times 2. 1, 2, 3. Yep, that's what we get when we do this portion here. Now, when we go to actually solve this piece, um, it starts off looking confusing. But the interesting part here is that these things divide out. So what's 2 divided by 2? Or anything divided by itself? When you do that, you just get 1. And we know how to deal with 1. We can kind of, for the most part, ignore it. And when we look at this, we end up with this 2 dividing out to 1, this 2 dividing out to 1, and this 2 dividing out to 1. What we're left with is just 2 times 2, and we can write it as 2 squared, right? That looks pretty simple. You all do this one here, the 4 to the 5th over 4 to the 1. I'm going to do the variable one because that one could be a little bit confusing since it's variable. X to the 9th will look pretty similar to the 2 to the 5th. So we have X times X times X times X, 1, 2, 3, 4, 5, 6, 7, 8, 9, all over X cubed. 1, 2, 3. All right. Now, when I do this, I have an X here divided by this X. These X's, X divided by X is 1, so that divides out. These 2 divide out to be 1. Then I have another X here divided by another X. That divides out to be 1. And then I have this also, this third X here, dividing out with my last and final X on the bottom. And what I'm left with is a 1 on the bottom that we can pretty much ignore. And that turns out to be X times X times X times X times X times X. And how do we write that? This becomes X to the 6th, okay? So we look at the very first column and the very last column. They look very different. Our first column, we see some division happening. We see a quotient happening, okay? Excuse me. what's happening there is that from the last column, or from the first column to the last column, we ended up subtracting. We subtracted the exponents. And if you didn't notice that, go back and look at it. We have 9 and 3. 9 minus 3, we get 6. We've got 5 and 3. 5 minus 3, we get 2. This is the one you guys are going to do with this 4. When you do that, you'll see that that also ends up getting subtracted. And then from that, we get this quotient of powers rule. And what that says is when the bases are the same, we subtract, oops, misspelled that one. When the bases are the same, we subtract exponents. All right, so I've written it out in expanded form in this middle column, and then I just wrote it out in short form over here. And we'll look at a couple more examples. All right, so first let's go ahead and simplify a couple of these examples. I'm going to do it in expanded form in one color, and then I'm going to do it using the quotient of powers rule in a different color. So with this first color, we've got, let's use pink. We've got g cubed times h to the fifth all over g times h squared. Now, if I go ahead and I write this out in my expanded form, that's going to be g times g times g times h times h times h times h times h all over g, since I only have one, times h times h. Now, using what I know about division properties and whatnot, anything over itself, even if it's a variable, if I divide something by itself, I still get 1. So what I have here is this g being divided by this g, and these things divide out to be 1. So we can pretty much ignore those. And then I have these two h's, dividing out with the two h's on the top. We could do one h at a time and then another h at a time, but doing 2 at a time is still the same. H times h divided by h times h, we still end up with 1 for our h's. And look at it, we've completely gotten rid of everything in our denominator. What's just there is just that 1 from those g's and h's. So we don't have to worry about it. What we have left, though, is 2 g's. So we'll have a g squared, and then 3 h's, and h cubed. All right, so that's how we do it with that expansion method that I've been teaching you all with the last couple of things we've done. Now, when we do it with the quotient of powers rule that we just looked at and tried, we start with g cubed h to the fifth over g h squared. That's going to be g, and our top quotient, our top exponent is 3 minus 1. And then we have h is going to be 5 minus 2. All right, and this h looks kind of not nice. So I'm going to redraw that one. Looks kind of like a U. All right, h. There we go. And what this turns out to be, can I scroll over a little bit? Yep, got a little bit of space left. G to the 3 minus 1. 3 minus 1 is just 2. That's going to be g squared. And then I also have my h to the 5 minus 2, which is going to be h cubed. In both of these different methods, one's a little bit shorter, but it's easier to make a mistake if you write it incorrectly. The other one's a little bit longer, but you're less likely to make a mistake. But we get the same answer, g squared, h cubed for both of these, all right? So using both of these methods, I want you all to try number 2, all right? If you get stuck on it, definitely come back to Zoom and let me know. Excuse me. Now, when we go and we look at these, let's look back, think back and look back at what we did for when we were doing multiplying these things. When we had the power of a power when we were multiplying monomials, that was going to be, where's my text box? That's when we had a power of a power, is when we multiplied. P-O-I-E-D, multiply the exponents. actually, let's say it a little different. With the same basis, I can't type. Same basis, we multiplied the exponents. All right. And then with the power of just a product, once again, with the same basis, we added a product. Oh, not added a product, we added the exponents. And so when we did a power to a power, that was a multiplication of those exponents. When we did multiplying those exponents, we added. When we multiplied with the same base, we added those exponents. With division, when we have that same base, we subtract, okay? So multiplication and division, those two are opposites, and so are addition and subtraction. So multiplication goes with addition, division goes with subtraction when we're dealing with the same basis, okay? And so that's what we get here, the power of a quotient. Or we get something a little bit different here. We have, with the power of quotient, we find the power of the numerator and the power of the denominator. The numerator of the denominator. All right, and if you don't remember what those are, the numerator is the top portion of a fraction, and the denominator is the bottom portion of a fraction. So when we look at this example, I'll do one of these and then I'll leave the other one to you. Number 3, we have 4x cubed over 5y to the 4th, all squared. When we do this, the way this thing says, we find the numerator and then the denominator. So when we do this, we've got 4x cubed, where's my pen? 4x cubed. Why isn't this writing? Oh, that's why. 4x times x cubed. And then we do 5y times y times y times y. All right, so that's it written out once. Remember, this 2 tells us how many times we're going to write everything that's in that parentheses. And I wrote out my exponents expanded. Excuse me. And then we write it again. 4x, x. So 4x cubed, that's where my 3 x's come from, over 5, y to the 4th, y times y times y. And then we do what we did before. The quotient of powers is the same as the power of powers that we did with the powers of quotient. I believe that's what it's called. Yeah, power of a quotient. When we multiply these two things together, when we do the exponent like it tells us to do, we do the same way we did with the not quotients, with just the regular monomials. And we end up with 4 times 4, which is 16. Then 1, 2, 3, 4, 5, 6 x's, x to the 6, all over 5 times 5 is 25. And then 4 y's plus 4 y's gives us y to the 8th. Okay. And that's how we do these things. The other method that I've kind of been touching on previously, and I touched on in the last set of notes, was that if you took this 2 and you added it to, or not added it, you applied the squaring of that 2 to every term, you get the same thing. So if you did 2, and let's do that in a different color. If I did 4 squared gives me 16. Then if I did x cubed to the power of 2, that means I'd have to multiply my 3 and my 2. That would give me x to the 6. And then if I did the same thing with the denominator, 5 squared gives me 25, and then y to the 4th raised to the power of 2, that's going to be that 4 times the 2, which gives me y to the 8, okay? So that's the same as it was when we were working with the monomials. I want you all to take some time and try number 4. And if at any point you get stuck or lost in all of this stuff, you can come back to the Zoom and ask the questions. I realize I'm probably talking a little bit fast, but this is a YouTube video, so you can pause it, rewind it, watch it again, and that'll help you out. All right, so the next section of the notes, we're going to explore what happens when our exponent is 0 or a negative, and we're going to look at it when we're going to complete. I'm going to complete one of these tables, and I'm going to ask you all to do the other two, just to help further that idea. So when we do 2 cubed, that's going to be 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, and we end up with 8. 2 squared, it's going to be 2 times 2, and that's going to be 4. Then 2 to the 1 is just 2. It equals 2. And then 2 to the 0. You all may not believe me when I do this, but I plug it into decimals for you so you can see what's going on and what's happening. If I plug in 2, and then you can hit this A to the B key, and that'll raise it so you can put an exponent in it. 2 to the 0. Oh, snap, y'all. We got a 1. 2 to the 0 isn't equal to 2, like most students will want to think, or it's not equal to 0 either. It's equal to 1. Okay? It's equal to 1. Anything to the power of 0 is equal to 1. And a lot of you all kind of realized that and caught wind of that when we were doing the Kahoot earlier. And then 2 to the negative 1, when we type that in, what do we get? If I type in negative 1 here, I get 0.5. 0.5 as a fraction is going to be 1/2. So 2 to the negative 1 is equal to 1 over 2. And then 2 to the negative 1 over 2 is going to be 0.25. As a fraction, that's going to be 1 over 4. Now, when we're doing these, it's going to be best for you to write these as a fraction and not as a decimal. That helps make the math a little bit easier. All right, and so we see what's going on. What I notice that looks kind of interesting to me is that 2 to the negative 1, well, 2 to the 1 is 2, and 2 to the negative 1 is 1 over 2. And then I see that 2 to the power of 2 is 4, and 2 to the negative 2 is 1 over 4. If I were to do 2 to the 3, I'll write it right here, but I have to erase it. If I were to do 2 to 3, or to the negative 3, I would take a guess, and I think you would also agree that this is a good guess, that since 2 to the 3 is 8, 2 to the negative 3 would be 1 over 8, right? Don't you think that? And since we have these different things, these negative exponents, one of the things that we notice is that it's going to be 1 over the value, okay? It's called the reciprocal. It gets flipped. And I'll type that out as soon as I find where my mouse went. There it goes. So with the 0 value, anything to the power of 0 is 1. That's easy to remember. I like that one. 0 is 1. All right. Anything to the power of 0 is 1. It doesn't matter what it is, how big the number is, how confusing it looks. It'll just be 1 if it's raised to the power of 0. And then if we have a negative exponent, we still take the number value. So if you wanted to type it in and you don't like dealing with the decimals and desmos, you could type in, instead of 2 to the negative 2, you could type in 2 and then just write 1 over 4 or 1 over whatever value it gives you. But anytime we have a negative, anytime we have a negative exponent, we're going to take the reciprocal, okay? Reciprocal. I think that's how you spell it. Yep, you take the reciprocal. And what that means is you flip it, okay? You type it into decimals to get the value, and then you're going to flip it, whatever value it is you get. So if I typed in 8 to the negative 4, I would type 8 to the 4 into decimals. Here, I'll show you real quick, just as an example. I'll type 8 over 4 into decimals, 8 over 4 into decimals. And then if I was looking for 8 to the negative 4, I would put 1 over this value here. And that would be my answer. That's what it's looking for when it says reciprocal, okay? So let's look at a couple of examples. And then before we get to those examples, anytime we're dealing with negative exponents, it's mega important to note that you will not be at your final answer if you have a negative exponent. So all final answers should have positive exponents, okay? All final answers should have positive exponents. So examples say simplify each expression so that all exponents are positive. As confusing as 5 looks, I am confident that every single one of you all can do that. And if you are confused about how to do number 5, scroll up and look at what we just wrote, okay? Let's look at number 6 instead, and then I'll save number 7 for you all. Number 6 says x to the 5th times y to the negative 2 times z to the negative 3 over x to the negative 1 y cubed. Anytime I do these, my first step is always to move my negative exponents first, okay? I always move my negative exponents first, and then I do whatever type of stuff needs to be done. So I'm going to start off by rewriting this with my exponents or my variables moved and those exponents as well. All right, so when I do this, I have x to the 5th, y squared, so that y squared needs to come down. But I have this x to the negative 1 that needs to come up. So since I'm writing my numerator first, I'm going to write everything first, and I'll keep the 1 there. Then that z cubed needs to go down. So my y, this needs to come down. So I have y squared, and then this z cubed needs to come down as well. And then the y cubed can stay down here. All right, so this is my first step, is to rewrite it with all positive exponents. So that way I don't have to worry about it, and I can just go through and do my expansion piece. So I have x times x times x, 1, 2, 3, 4, 5. And then that's last one with the 1. I got that on top. And I've got y squared, y, and then z cubed, and then y cubed. And now what I need to do is just combine things that I need to combine and rewrite this in a simplified form. 1, 2, 3, 4, 5, 6 x's. So it's going to be x to the 6 all over 1, 2, 3, 4, 5 y's. So that'll be y to the 5th, and then z cubed. I didn't have anything to do with the z, so those stay the same. You all go ahead and try number 7. And remember, when you're dividing numbers, those things still function as regular numbers. So this 32 over 4, you're still going to divide 32 into 4, all right? And then number 8 is there. And then what we have left is just going to be the summary. All right, so I know this could be a little bit confusing, but I want you to take some time, fill in the summary. If you got confused, tell me what spot you got confused on. If you were able to figure out what was confusing, tell me how you figured that out, all right? If you weren't able to figure it out, you can write that in there as well. After you finish with this stuff, there will be an IXL and some classwork for you to do. And like I always say, if you get stuck, come back to the Zoom chat and ask for help. All right.